Linear functions. In this video, we hope to deepen our understanding of constant rate of change. In the opening slide, we see a graphic organizer called the rule of 4. This shows the contextual representation of a function, its equation form, its graphical form, and table form. And we're showing a linear function in this rule of 4. We'll start with the word problem, or the contextual representation. Joe planted a vineyard one year with 5 vines. He added 2 vines every year. So with a linear function, there will be an initial value and a constant rate of change. The initial value is 5 vines. The constant rate of change is 2 vines every year. In the equation form, y equals 2x plus 5. 5 is our initial value. 2 is our constant rate of change. The graphical form, we can see the initial value is where the line goes through the y-intercept, that's at 5. But the rate of change can be found by looking at rise over run. The rise is 2 and the run is 1. So the constant rate of change according to the graph is 2 over 1, or 2. In the table, we can look at any 2 ordered pairs, and we'll look at the change in y over the change in x. So y, you can see, to go from 5 to 7, I'm increasing by 2. To go from 0 to 1 on my x, I'm increasing by 1. Change in y over change in x will be 2 over 1. That is my rate of change as seen in my table form. In the next example, we're given 3 different representations of linear functions. And we're asked to determine, is this function increasing, decreasing, or constant? In the first example, it's in y equals mx plus b form. The slope, the m, is 2. So this function is increasing because it has a positive slope. In the second equation, this has a constant rate of change. And we can think of it like this. No matter what the x value is, if the y is always 4, this will be represented graphically by a horizontal line going through the y-axis at 4. Now with the table, let's look at change in y and change in x. Y decreases, right? To go from 4 to 1, it's decreasing by 3, and x is increasing by 1. So the change in y over the change in x is negative 3 over 1. If I were to graph these points, we would see a decreasing linear function. Sometimes we'll be asked to compare 2 linear functions. Here we have linear functions f of x and g of x. We know they're linear functions because they're in the form y equals mx plus b. You can see that f has an increasing rate of change and g has a decreasing rate of change. But we don't have graph paper, so we can consider some of these questions algebraically. The first question says solve f of x equal to 0. Well, I'm going to take my symbolic form for f of x, my 4x minus 5, and I'm going to set that equal to 0, and then solve for x. I do that by adding 5 to both sides and then dividing both sides of the equation by 4. So I know that my function f of x has a value of 0 at x equals 5/4. In other words, it goes through the x-axis at 5/4. Okay, now where is f of x greater than 0? I can do a similar process as in part A, but instead of an equal sign, just use greater than 0. So this tells me that my function is above the x-axis, or my function has a value which is positive where x is greater than 5/4. Where is f of x equal to g of x? I'm going to set the 2 expressions equal. So I'm going to write 4x minus 5 equals negative 2x plus 5. And then to solve for x, I add 2x to both sides of the equation, and I add 5 to both sides of the equation. Finally, I divide the equation through by 6, and I can just simplify my fraction, x equals 5/3. So what I know is that the 2 functions, graphically, they're going to cross at an x value of 5/3. Now where is my function f of x less than my function g of x? Less than or equal to. So I go through a similar process as in part C, but instead of equals, I use less than or equal to. And again, I solve for x. So I know my function f of x basically is below g of x when x is less than or equal to 5/3. Okay, part E, let's piece all this together graphically and make sense of it all. Graph y equals f of x and y equals g of x and label the point that represents the solution. All right, let's start with graphing f of x. Well, here's my coordinate plane. My initial value is -5, so that's my y-intercept. My slope is 4, so I'll go up 4 and to the right 1, and I'll connect these dots with a straight line. There's my function f of x. Now g of x, my initial value, or my y-intercept, is 5. My slope is -2. I'll connect those dots with a straight edge. And where these two functions intersect, that is called the solution. I know the x value of my solution because I solved that earlier in part C. So my x value is 5/3. The question is, what is the y coordinate of this solution? To find the y coordinate, I could take my x value and substitute it into either function, f or g. I'll substitute 5/3 in place of x in my f function. And I will now simplify this expression. I'll get 20 over 3 minus 5, but I'll think about the number 5 as 15/3. Reason being, with fractions, I want the common denominator. So my y value is 5/3. So I know that the solution, that is the point at which the functions intersect, is 5/3, 5/3.